All right, hello students, my lovely Pre-Calc 11 students. This is not my first attempt at this video, but I'm hoping this will be the one that I don't have to stop halfway through and start over again. So fingers crossed, this works out. This is our first video, so even though it might be the first time I post it and not the first time I've practiced it, it might still be a little bit rough and trying to work out the kinks and how we're going to do things. So in talking with Mr. Henry, who's the Pre-Calc 12 teacher, when we spoke, he said one of the most important things that he's hoping students will have from Pre-Calc 11 going into Pre-Calc 12 next year is that they understand how to solve quadratic equations. That's the big thing for him. So that's what we're going to focus on. That is our goal for the rest of the semester, is to get an understanding of how to solve quadratic equations. So we're still going to continue on with those notes and with understanding how that works. And in order to know how to solve quadratics, we need to go over how to factor expressions. These are things that you've been working on in Math 9 and Math 10. So we're just going to review those concepts first before we start going into quadratics and how they work, and then on how to solve them. Again, that's our goal for the semester. If we zoom through everything and can add on some rational expressions, great, but our main focus, our main priority is to make sure everyone has an understanding of how to solve quadratic equations. So to do that, we're going to continue on with those note packages that I wonderfully and painstakingly prepared for you with Unit 3, which is factoring. So if you can get those notes out, we're going to continue on with Unit 3. Now, if you don't have your notes, if you lost them or they're still in the school and you're not able to retrieve them, whatever reason, I am going to try to post them on the Teams and on the website so that hopefully you can just print off the applicable ones. Don't print off the whole entire thing because we most likely will not be going through the whole entire thing. If I'm not able to post it because it's too large of a file, I will cut it up. I'll hack it to pieces and post it in chunks. Sounds a little violent, but I've been cooped up in the house for a number of days. All right, so here we go. We're going to review some concepts, some terminology first. This little lovely -2 here is what we call a coefficient. We use that word in chemistry as well. We use coefficients to balance chemical equations. You're welcome. There's another coefficient present here, and that is the 4. All right. We also have some letters going on. This X represents a number, any kind of number, any real number. If it was imaginary, it'd be represented by an I. So this X is a variable, and we don't know what it is. And there's another X right there, okay? This part right here is called a term. There is another term present. It's this one here. That's another term. The sign, whether positive or negative, directly preceding the term stays with the term. So if the first term didn't have a sign in front of it, it's assumed it is positive. This whole thing is called an expression. It is not solvable when it's an expression. All that you can do with an expression is manipulate it. You can expand it, you can factor it, you can manipulate it, but you can't solve for anything. You can't solve for anything unless it becomes, or it is, an equation. So an equation is when it's equal to something. So you have some sort of thing to solve for. Okay, so with factoring, there's many different ways to factor, and you would have been taught many different ways. And I might do a separate video going through some of those ways and reviewing some of the concepts that you did before, but we're going to do the short version of factoring. So if you look at example 1a, we have an expression with 2 terms, and to factor this is an expanded version. To factor this, we want to find what number is the greatest common factor for both terms. So the term positive 5x and negative 20, what is the largest, greatest common factor? the greatest common factor. So we're going to look at the numbers first. What's the largest number that will divide into fully 5 and negative 20? And the answer is positive 5. So that is part of our greatest common factor. And then you look at the variables. Do both terms have the same variables? Do they have the same amount of variables? What's the greatest number of variables that can divide into each of those variables? And the answer here is that x is not a common factor because it's not common with the two terms. So the greatest common factor is 5. 5 will divide into both of these terms in the expression. So to write this in the factored form, we would write 5, because this is our greatest common factor. And then we would write what the result is if we were to divide 5 into both of these expressions. So 5x divided by 5 leaves you with 1x. But of course, because we're lazy mathematicians, we don't write the 1. And negative 20 divided by 5 is negative 4. Okay, so what goes into the bracket is basically what's left after you divide that greatest common factor out. Okay, so when we went from this expression to this expression, we didn't actually change any values. Nothing was changed. We just manipulated it. We manipulated it by factoring. Okay, and what I like about factoring is that you can always check your answer because of course you can go back the opposite way. You can expand and check your answer. And how you expand, ooh, my sideways writing needs some work, is by the distributive method. So I don't really know if I have enough room to do that with my lovely writing, but if we copy out over here and just do a small check, we have 5 times x minus 4. And to do our check, we're just going to multiply 5 by x, which is 5x. I'm going to multiply 5 by negative 4, which is negative 20. Now, did we get the same thing that we started out with? We did. So that means we factored it correctly, or at least one way correctly. I mean, sometimes we might not have we might need to factor again because we didn't actually take out the greatest common factor, but it is factored, and it is factored correctly. So what we're going to do is practice. So pause the video now and give B and C a try. All right. I don't know if you did that or not, but I'm going to assume you did. Good job. All right, so we have 21x squared and 7. The greatest common factor that goes into 21 and 7 is 7. Even though there's an x squared, the second term, which is positive second, does not have an x, so we can't have x as a part of our greatest common factor. So 7 goes on the outside because that's our greatest common factor. If we divide 21x squared by 7, 7 goes into 21 3 times. The x squared just stays x squared because it was not reduced or factored out in any way. And then 7 divided by 7 is not 0. It is 1. Okay. So there's the factored form of that one. And of course, you could check by redistributing out or expanding. Okay. Now let's look at this last one. Ooh, there's 3 terms. Moment of panic sets in. What do you notice about all 3 terms? First of all, don't panic. Break it down. Focus on just the numbers first. What number goes into 6, 12, and 4? The greatest number that goes into all 3 of those numbers. You might want to say 6, but 6 doesn't go fully into 4. The greatest common factor for the number is 2. So we're going to divide all the numbers by 2. Just 1 second. So 6 divided by 2. So we're going to have, but we're not done, but our part of our greatest common factor is 2. Sorry, I get very flustered when the kids knock on the door. So the next thing I'm going to do is, now that I've done the numbers, I'm going to look at the variables. What's the greatest number of x's that can divide into every single one of these terms? And the answer is only 1, because although there's 2 x's here and 3 x's here, there's only 1 x in that third term. So the most amount of x's that can divide into all 3 terms is just 1 x. Okay, so the greatest common factor for these three terms for this expression is 2x. So when we're figuring out what's left after we divide 2x into or out of basically all three of these terms is we look at the numbers with the numbers and the x's with the x's. So 6 divided by 2 is 3. X squared divided by x is just x. Okay. Positive 12 divided by 2 is positive 6. And x cubed divided by x leaves you with x squared. 4x divided by 2x. So again, 4 divided by 2 is positive 2. And x divided by x is 1. So, and 2 times 1 is just 2. So we, in this case, can just drop it off. All right. The other thing I forgot to mention is that we normally, this is not incorrect the way that this is written right here, except for we tend to write our expressions with the highest degree written first. So this term has a square in it, so we write that's a higher degree than this x that has an exponent of 1, and this one that doesn't even have a variable goes last. So that's usually just the standard in which we write it. Neither one of those is technically more right than the other, except for we try to always write it with the term with the highest degree first, so that we get used to seeing things in a certain way. All right. Example number 2. So with this one, we have a moment of panic because it's like, wait a minute, that doesn't look the same. But if you just think about this stuff in the bracket as being like a green box, is there something, and then this is a huge term and this is another huge term. Do both of those massive terms have something in common? Of course they do. They have the thing that's in the green box that is common, which is x plus 2. And I'm just going to leave it in a little brackets, right? So they have x plus 2 is common. So it's not like a singular thing, but that's okay. You just leave it inside the bracket and it's common with both massive terms. So it's going to be divided out. So again, what is common is x plus 2. That is the greatest common factor. And what's left gets written here. So if we look at this term here, and we're dividing out x plus 2, well, if x plus 2 divided by x plus 2 gives you 1, and then you're just left with this x. So that's what's left when we divide x plus 2 from that term. And then if we do the same thing here, we divide out x plus 2 and x plus 2, we're just left with this here. And remember that the symbol directly preceding the term stays with the term. So that's going to be a minus 3. Okay. And that's it. That's all she wrote. So I would like you to pause the video here and try C and B, and then just take a wee little stab at D. It looks a little different. There's a little extra step of manipulation involved there, but just give it a try. Okay. Thank you for trying. All right, so here the greatest common factor is 4b plus 3. Okay, so the greatest common factor comes out 4b plus 3, and what's left is 2x plus 3. And there you go. You have just written the factored form of that expression. Okay. Now for B, I just realized I didn't go in alphabetical order. I apologize to my fellow A-types there. We have, ooh, no, I didn't want to do that. I don't know what that is. We have x plus b that is common with both terms. So x plus b squared divided by x plus b doesn't totally cancel it out. We're left with x plus b, which is our greatest common factor, gets divided out. But what's left inside is you have a whole nother x plus b, right? X plus b squared is x plus b in brackets times, in brackets, x plus b. Okay, just go, you can go. Okay, ask your brother for help. All right, so the last one is, we're left with -2. Okay, and that's what this one looks like. And then if you look at what's in here, I just realized you can't see me wagging my tail. I'm waving my pen, is that you can just take those brackets away. So it becomes x plus b times x plus b minus 2. There we go. So the last one is a little bit of a tricky one. You have something that looks like this and then something that looks so similar, but it's not the same thing. So you have to do an extra step of manipulation to make it the same thing. So a minus c, if you divided out a -1 from it, it would become a -1 times -a plus c. Then if you rearranged it, it would become a negative c minus a. Okay, and so then here we can replace this with that. Right, so I'm going to rewrite this because I just made a mess of that area. So it's 2a c minus a minus 4a, or is that a 4c? I can't even read it anymore. What does it say under there? Oh, it's a 4c. Oopsie doopsie. All right, 4c. And then instead of writing a minus c, I'm going to write negative c minus a. Okay. And then I'm going to do another little mini step. This -4c and -1, I'm going to multiply that out, because really this is -4c times -1 times this whole thing in brackets. So I'm going to rewrite this out again as 2a times c minus a, and then -4c times -1 is positive 4c times c minus a. And then look at that. Isn't that pretty? They have a common factor. They both have c minus a now, the same thing. And we're left with c minus a as our greatest common factor, which leaves us with 2a here, and it leaves us with positive 4c from the second term. And there we go. We have factored binomials by factoring out the greatest common factor of both terms, leaving the greatest common factor on the outside and leaving what's left after we divide out on the inside brackets. What I'd like you guys to do is try that lesson 1 section of the factoring practice handout. Let me know if you have any questions. Thank you so much for joining me. I'm going to find out what my daughter needed, and I hope you guys are all doing well.